So I'm going to speak first about the underlying technology. I have a couple of frames on that. Then we'll talk about functional testing, in particular, what has become eValid's forte. That is the ability to handle complex AJAX synchronization issues, which other solutions, and we know now in 2011 that there are a lot of other solutions, but we don't know of any that do quite as good job of synchronizing AJAX as efficiently and as accurately as eValid does. The third part, that's the first part. The second part will be a discussion now of testing mobile devices. We've heard a lot recently about mobile, and in fact one can't get on a bus or an elevator or get into a car without seeing somebody driving with a mobile device in their hand. I'm sorry, cancel that. I'm not endorsing driving while texting. But anyway, mobile devices are pretty important, and we'll talk a little bit about how eValid handles that. But as Rita pointed out, the real underlying issue for people developing web applications, whether they're intended for the desktop, as you're seeing on your screen now, this is obviously a desktop, whether they're intended for a desktop or whether they're intended for a mobile device, the real issue is performance. And performance means response time. And I can recall a decade ago when people said, if it isn't showing up in 3 seconds, the users will click away. And I read an article yesterday that said for mobile devices, that threshold has been reduced to 1 second. That if people don't see it right away, their attention is lost and away they go. Okay, so let me start with the underlying technology. First off, what you're seeing on the screen here is in fact the eValid product. It looks like a browser because in fact it really is a browser. This is based, the eValid engine is based on the Trident rendering engine, and so that one means when eValid runs, and let me just show you there's a help about in here. I want the other one, the system information. When eValid runs, it picks up dynamic link libraries from the IE version that underlies lies on the desktop. So in this case, I'm using an older one, IE7, but eValid works fine on IE8 and on IE9. We designed eValid, implemented in C++ on BS28, 2008, to be a fully complete web testing solution. Because eValid is knowledgeable about the details of a web page, and let me just show you one really simple illustration of that. I'm going to turn on the page map and click on this top page and have the page map show you the, I'll draw that out a little bit so it's a little bit bigger. I'll have the page map draw the complete tree of document, object, model elements that exist on the underlying page for Bing. While Bing looks like it's simple, Bing is not simple. Bing is quite complicated. So eValid, because it's built as a browser and because it's built as a freestanding Windows application, we believe a pretty well-behaved one, we wind up with efficient, low overhead operation, and an important factor is that it's a self-contained desktop app. And that means, as you'll see later on, that we can run 2s or 5s or 10s or 20s or 50s, and we'll do an illustration of 100. We've had as many as 1,000 eValid browsers running in parallel on a machine for purposes of server loading. And the neat thing about that solution in terms of server loading is every eValid instance that's running is its own separate process. Another important advantage, particularly when we talk about AJAX, is that the eValid engine does not, repeat not, use, I guess the word not is right there in that sentence, does not use the JavaScript engine. There are other solutions, I'm sure some of you are familiar with them, other solutions that rely on feeding JavaScript into the browser and having the JavaScript drive the, they call the JavaScript API browser interface, or the iHTML doc2 interface. I've got technical in a hurry. But we do not. eValid does not drive JavaScript to get the results that it gets. Instead, eValid makes direct calls into the events in the DOM at the same level as a user. So that means that if an AJAX application is running in the browser face, which is what you're seeing here, for example, that eValid's recording and playback activity don't interfere with what goes on in AJAX. And this is very important if you're concerned about realism. So this is eValid's second main forte, is that while we can handle, and I'll show you an example, handle Ajax synchronization very well, we also do it with extremely good accuracy without interference. Now, there's some other design features which are, I'll just take you on a sort of a tour here. As you see in a browser, there are all sorts of favorites. There are some tools. The recording and playback is done from this set of pull-down menus. I won't go through all of this, but I just want to indicate that there are pull-down menus and a playback menu with playback options. There's a load test option. There's also a site analysis feature. We won't talk about site analysis except to mention that it's a spider in the browser. There are some very substantial settings, and this is the full menu. Gosh, I'm not going to go through all of that, except maybe I'll point out that one of the key factors is what's called the playback multiplier, or the wait time multiplier, and I'll set that to a different value. And then there are various windows, including the script window, which is down here, and the log window, and all of the features of eValid for user interface are all text inputs, outputs, and every feature that's available on the desktop GUI face, whoops, a little bit overloaded that one, every feature is also available in the batch mode. And the batch mode is actually the mechanism used by eValid to run multiple simultaneous browsers. One of the key factors, and this is the third advantage eValid has, is programming skill is not required. Programming skill is desirable. Programming skill helps, but you don't have to be a programmer, and you don't have to get involved with compiling a C++ script or editing or debugging a JavaScript program. You don't have to do any of that with eValid. eValid is designed for the guy who wants to get a result quickly, and you'll see from the script examples how relatively easy that is. Okay, so about recording. This is an engine that does record play, and let me just comment that there are many people who object to the record play paradigm, and I'll make some points about this later on. I'm just going to make a recording so you see what's going on. eValid has deleted all the cache and the cookies, and I'm going to test for something like this number, and I'm going to type enough letters in so I don't use the autocomplete feature. That's tested a little bit differently, but once I get to the end of the result, I'm going to say, oh sorry, and then record, validate, selected text, and you'll see that eValid puts into the script a phrase called validate selected test. So I've recorded in just, how long did that take? From 12:09 to 43, something like 20 seconds, and because I was talking, I recorded in 20 seconds a test which, when I play it back, will go to the Bing homepage, it actually waits a number of seconds, and then it goes and types some stuff in, and then goes and I got a red line. I didn't get the right answer. Well, so much for, let me try again. You know, Whaley, can you help? What did I do wrong? 5, 5, 5, 5, 5, 5, 5. I see. I probably want to search that. There we are. And now we'll go down here and check by Natia. We'll take that one. And I'll do the Control-T, which is the same thing as typing the command. All of these commands, by the way, have shortcuts. If you become familiar with eValid, you can make these recordings even quicker. So I'm playing this same test back, and now I did the right thing. And you'll see that we go to that page, and then we'll validate the selected text, and we get a warning message because something changed along the way. So let's close this test off and look at the event log. I mentioned the event logs and the scripts are all blank delimited or tab delimited text files. Makes life very, very easy that way. eValid is widely reputed as the easiest possible engine to integrate into whatever else you've got going. So there was a warning somewhere, aha. This form couldn't be found at the expected index, but what eValid did was, because it uses what's called adaptive playback, eValid compensated, and that's the adaptive playback feature right here. eValid compensated for the fact that something moved around, and let's face it, if you didn't have adaptive playback, most of your recorded from life tests would fail as the websites change. So we did something pretty unique, and we built in this adaptive playback feature, which basically removes the brittleness of most test playback activities. There are, you get complete logging, and I'm showing here on this screen, while that settles down, so that you can all see that. I'm showing that eValid, now let me emphasize, eValid is not driving HTTP directly. In fact, eValid is driving the browser. This playback drives the browser. It's the browser that causes this HTTP activity. But what we did is we put a little wrapper, a little timing wrapper around each of the threads, and there are multiple simultaneous threads downloading. So if you take the total time in this column, those are the milliseconds that each thread took. If you take that total time, that'll add up to more than the 2.297 seconds it took to download the 149 kilobytes of that page. I hope I didn't mess myself up here. So eValid is able to measure the time and the size of every page component. Let me tell you that the Bing page is a relatively simple one. If you go to something like CNN, which I won't do because it's so busy, you'll see that there are several hundred page components, and in some cases as many as 5,000 page elements. So very complicated stuff inside, very simple from the perspective of building a test for it. Okay? Now, this particular test that I ran, I'm now at my technical limits of what I'm going to try to do as a seminar speaker. I'm going to use a tried and true script that already exists. That way I can't make a mistake like forgetting to click search. I'm going to go to another page, which is an Ajax application, and this goes off and does a particular Ajax activity. And we're talking now about the process of assuring synchronization of Ajax. Now we have automatic page synchronization, and I've seen many people in the last year or so. Again, lots of activity in web testing these days. Lots of smaller companies joining in, and we welcome all of them. That's fine. The more the merrier, I guess. We've been here the longest, and we have the I can say the primogenitive. I get to use a big word. We have the primogenitive solution. We were first. The stuff I'm talking about today we've been doing for 5 years or more. So here's this playback script, and it played back as you see normally. I'm now going to change the settings, record play preferences, to multiply the delay times by 0. All the wait times of playback will now be multiplied by 0, and the prediction is that this previously wait time synchronized Ajax application is now going to fail to synchronize, and I'm going to get a red screen when this thing runs. And the red screen means that there was one or more errors showing up in the playback. Wham, there's the red screen. Let's just look at the event log. I'll close this and look at the event log to see where the errors were. Item, for example, here, select one in that thing. In that particular, here's the command, input value 0, in Windows 0, index 35, select one, car, S-Class 500. Oh, that sounds like a Mercedes S-Class. And it turns out that item is not a select item. We couldn't find a match. Okay, so eValid's adaptive playback couldn't find a match. That's because the page wasn't completely loaded. So I'm going to go ahead and suggest that let's just look at the next one in the sequence, Form 2. And I want to bring this up so you can see what was going on. In Form 2, we took the command down here where we added a synchronization. And what we did was we synchronized on a property. Now, these commands were edited in. Now, let me speak a little bit about record from life versus editing. We believe in getting the answer in the least effort, shortest time, most straightforward method. Okay, what we generally do is record from life. That is, we just make a recording, and eValid picks up all of this detail, index numbers and contents, and whether or not it's a navigation, what the URLs are. If you tried to code this by hand, well, I suppose you could do it, but we don't think it's a very good idea to do that. We think it's a much better idea to add the synchronization stuff in manually. So we did a sync on text here. We added that one in, and then later we added another one, which is sync on an element property. We typed those commands in. So now with the delay set to 0, we should be able to get good synchronization. I think that's correct. Willie, does number 2 give me good synchronization? I think it does.
Yes, it should.
Yes, it should give us good synchronization. All right. Yes, so now this playback synchronizes and the wait time is 0. If I look on the playback summary, we find that the wait time was 6% of the total and a duty cycle of 94%. That means 94% of the time the eValid browser was doing work, not sitting around in a wait state. Okay, the third example in this sequence goes one level further, and in this case we changed the command. Now I've illustrated wait time synchronization, recording, validate selected text. I can use as a script conversion methodology, I can use a technique which says I can use the page map to find elements, and I can add element synchronizations like this command. I can even eliminate commands like follow link and replace them with DOM manipulations that read as the following. Now what that command sequence right there says, start at the top of the page, which is index 0. Computer science is index 0. Find the element that says HTML controls example, where the inner text matches that, and then do a follow link from that location. This passage of commands, the wait is simply already there. That's going to be monitored out. This passage of commands makes no reference except for the page number, which is the window number. That's the parent window. It makes no reference to anything other than a place on the page where the HTML controls example, where the inner text says HTML controls example. So this particular variation of the playback, and I'll play it back here while it's playing, we can talk about it. That particular variation of the playback is basically invulnerable not only to variations in where things are located on the page, variations in synchronization, but also to the way the page is laid out. And you might say, oh, that's a green screen. Not even dependent on anything except that the page be essentially the same content. Now, people always ask at this point, well, doesn't that mean, isn't that the perfect test? Isn't that the Lake Wobegon test? You remember Lake Wobegon. That's the little town up in Wisconsin where all the men are handsome, all the women are good looking, and all the children are above average. That's a Garrison Keillor invention. So the Lake Wobegon test is one that always passes, never fails. Yeah, right. We all know the tests that always pass don't give you any new information. So let me tell you what I've told you then before we go on to discussing mobile. What I've illustrated is that a very sophisticated product has been built and is widely available, used in 1,000+ installations all over the world, and used millions of times a day, hundreds and thousands and millions of times a month in monitoring mode and functional testing mode. And this product is able to do everything that every other product can do, but we do it with efficiency and reliability that is unparalleled. Okay, so let's talk about mobile. People ask the question, well, do you handle mobile applications? And I always come back and say to them, well, let's talk about the architecture of a mobile application and how does it differ from the architecture of what you're looking at on your screen, which is server to web, actually server through load balancer to web to laptop or desktop to the screen. In a mobile application, you have a server stack, but then you have the server. There are two more parts to the transfer. There's an intermediate, I'm going to call it to the tower. That's to the wireless distribution system. Verizon, AT&T, T-Mobile, I guess there are lots of them. I don't want to give any one of them So there's a difference in the delivery of information, and there's also a fundamental difference in the client and the device. As we know, the devices, the handheld devices, use a much lighter version of a web browser, and to minimize transfer delays, most websites actually diminish the total volume of data that's delivered to a mobile application in order to enhance performance. Okay, let me look at this at the other perspective. If you're trying, suppose you're managing a mobile application and you're looking around for what opportunities do you have to optimize performance. Well, you actually don't have much control over the device. The people who make all these devices, and I won't name all those, iPhone and Motorola and Google and whatever, Microsoft. All of those companies make the devices, and you can't control how fast they respond. You really, as a device, as an app builder, can't control how the wireless network and its interaction with the wireless devices works. And we all are familiar with the complaints that happen. You can control a little bit how the server delivers over the internet by providing things on the server like load balancer and making sure you have good bandwidth. And of course, at the server side, you can decide, if you're serving a mobile application, to reduce the total content of what's being sent. So we looked at this and we said, well, gee, since you can't fix everything, that's my last line, since you can't fix everything, well, what really is the case? All we really need to do is to have eValid apply to a mobile application, is to have eValid pretend that it is a different browser than the one that you're used to thinking of. That is, this browser thinks, let me just show you again. This browser that I'm using, this version of eValid, reports itself as IE7. So a couple of years ago, we built a special command into eValid called the set user agent string command. And let me see if I can bring that up. Can't bring up that command when I want it, but let me show you an example of that command by, yeah, here we are, set user agent, and we'll pick that up. The set user agent string basically says to eValid, pretend that you're something other than the IE browser. And that command is just this command right here. Actually, this is the command that declares to the world that after this command is executed, the servers should treat this particular browser as a Mozilla /4.0 compatible MSIE 7.0, all of those strings. I don't have the page at easy reference, but there is a completely simple page where you can get all these data. It's on our website to get all that data. So here's a script where we go to Verizon Wireless, for example, as IE, and then here is the command that says, let's pretend we're an iPhone. Now, I don't want to say we're endorsing any particular application. We picked iPhone because it was alphabetically the first one on the list. The lowercase I preceded all the other ones. I think that's a fair example. So we set the user agent string, and then you have to be a little bit careful about the cache and the cookies. You want to run your tests with the cache deleted, and that's this command, delete cache and delete cookies, because the cache on your desktop is a little bit different than what's on a mobile device, but you want to make sure for purposes of performance measurement that you measure the behavior of a mobile application at the time it's downloaded onto the mobile device. So let me go ahead and start this command up, and you'll see what's going on. I've got a page here which does Verizon, Amazon, Meebo, Sony, what's the other one? I lost it. Sony, Bloggy, and Samsung, 5 different mobile devices. And I'm going to just let this run. And you can see that eValid is going to bring up the Verizon Wireless page. This is the first one is as eValid, and the second one is imitating, spoofing, pretending to be a mobile device called an iPhone. All right. And I set this script up so it comes to a breakpoint. And it's interesting, you see that loading symbol? That's a significant thing that tells you right away that the iPhone version of this particular app, which now includes that rushing sound, by the way, if you heard that, we wondered what that was, and then I kept realizing that this is what this playback is. I stopped the playback here in this one so you can compare these two screens. I've got them showing here. It's a Flash app. It looks like the server ships out 2.8 megabytes versus 2.6 megabytes for the IE versus 4 gigabytes, a full 2.8 gigabytes. Yeah, 2.8 megabytes. Let me go to the next one, which is now going to be between what the server delivers to the browser as an IE browser as opposed to an iPhone browser. And then we switch the user agent to an iPhone browser, and we deliver this. So the truth is, you can see in actually my screen right here, you can see that. I didn't realize I had it here. They deliver 5% of the data volume, 1.2 megabytes to a desktop, 68 kilobytes. 68, that's a point, 68.873 kilobytes to a mobile device. And then we can tell eValid to pretend that it's a mobile device, and you can test all of the essential properties of the server device stack. You can test everything that's important to you using the eValid engine. So you don't really need to have a mobile device playback engine. You don't need to spoof the imitation. The download sizes are explicitly measurable inside the eValid content, inside the eValid event log, and the page content is very interestingly rendered fairly well. If you look at the rendering, and people have asked, well, gee, how come the IE browser renders this so well? Most people these days adhere to what's called the JavaScript ECMA standard. I think it's ECMAScript 4 standard. These are independent JavaScript. So the behavior, if I wanted to run a dynamic test of this Amazon app pretending I'm a valid browser without actually being on a mobile device, this is a tremendous advantage in terms of cost and difficulty. Now, I don't think there's much of a problem considering that eValid has the ability. I'll stop this script and it will show no warnings, no errors. It shows a warning, and I want to kill these things off so I don't utter my eValid makes eValid an ideal candidate for driving server loading experiments as well as mobile device application experiments. So the next section I'm going to ask when Whaley will describe setting up and running a multiple browser playback load test, and hang on to your seats because you're going to see at one point that we can physically get on the screen. So Whaley, over to you.
Okay, hello everyone. I'm going to switch.
I can see it now. Thank you.
Okay, for starters, we have this script called test2.evs. And basically, it's going to open up a browser, go to www.google.com, and it's going to perform a synchronization check with one of our web pages. Basically has a go and a stop running marker on it. And after the synchronization is found, then it's going to download a local 100 kilobyte HTML file and record some data on a download time, etc. Okay, to encase this within a load testing scenario, first off we have our load test scenario editor, and basically that allows you to add your script file. In our case it's going to be test2.evs, and you can multiply it as many times out wide that you want browser wise. So my script that I've prepared ahead of time contains 100 lines, and that means it's going to invoke 100 instances of the eValid browser, and it's going to run one iteration of this test2.evs file.
Whaley, I think you have a 2 wide there, or do you have 100?
I have 100 set up.
Okay. Oh, here. There you go.
Okay, and so here's the load test scenario editor with our 100 wide times 1 iteration file loaded. And
we use the term wide. We use the term wide to express the total number of times the script is repeated. I think here there's just one. We call that the depth, so it's the width and the depth.
And here's the actual script file view of the same that was created using our scenario editor. And I'm going to simply go ahead and click play. And it's going to take a couple minutes for the 100 browsers to ramp up. Before you see the eValid load test monitor, and this shows the real-time run counts of each of the browsers in action.
Right. Now, the interesting thing about this special script called a load test script, we've repeated the same, we're running the same test 100 times. You could have 100 different browsers, each running a different script. You could have 25 doing script 1s, 25 doing script appropriate. We don't know how your users are going to be partitioned. You know how your users are going to use your application. Okay. Most times when we do this kind of work, by the way, on a survey of users of eValid, and most customers find that they have 5 to 10 basic functionalities that they want to put in the mix. So you see typically a couple of 10% and a couple of 20% and maybe a 50% division in that activity. So there are 62 eValids launched. Go ahead.
82. Almost there. 84.
Load test playback synchronization page up is that we want to make sure that we can start all 100 browsers at identically the same time. If you didn't use this probably want to have them in staggered starts. Okay.
Okay, if you're able to see my desktop taskbar at the bottom here, you'll see there's 100 instances of the eValid browser up, and I'm going to place them side by side.
Now comes the picture that's amazing. So here are 100 browsers, and now we're familiar with other technologies, and we don't know of any technology extent, that means any technology at all anywhere, that allows simultaneous real users. All the other solutions somehow simulate real users with HTTP protocol activity or limited to a maximum 6 to 8-way playback. Here we really have 100 simultaneous browsers. Go ahead, Willie. Go ahead and start.
Okay, I'm going to open up one of the browsers so you can
open
click
one of them so we
inside
see.
the button. Each of the browsers will play back the script with one iteration and close itself.
Right. Each of the browsers has a loop waiting to see. My screen doesn't show. Oh, there it is. Okay.
They're trying to browse.
Right. So they're all waiting for the same event. So we click that event and all 100 will start.
100 kilobyte HTML file.
Okay.
My meeting has delayed.
There. Now we're running. And now what will happen is all 100 of these browsers, the script is to say about what the...
I had indicated that it goes to google.com, syncs on the word running, and then downloads a 100 kilobyte HTML file.
Right, and then disappears. Right.
This is Rita speaking. I noticed that it's really slower than when we do the tests without going through the webinar. Could it be that the software of the webinar is interfering with this performance?
Yes, it could be.
Yeah, that definitely adds a layer.
And so here is the...
after completion, it took lapse time. 3 minutes, 4 minutes. There's still 2 more lingering around.
Yeah, there's still a couple didn't get control. Now he ran. Yeah. So there are sometimes performance issues with the interaction. All right. Will you be able to show the little chart?
The fastest time will be in blue. Slowest time will be in red. And then we also have a where's our visuals, the load test chart.
That shows the response times of that single playback, and it starts from the beginning number to the end and hovers around 100 to 200 seconds. That includes all of the delay times, vary only by plus or minus 10% or so. So that means that the performance variation is due to the web. So, okay, so let me have the screen back, Willie, and let me try to finish up.
Okay.
Very good. Thank you, Willie. There's my screen. You should be able to see my screen now. Now, what you just saw was 100 browser users running in parallel, and we get that on when we go to 1,000 browser users, what we typically use is a cloud image where we actually use this one, a quadruple extra large cloud image, which is 68 gigs of RAM and 8-core CPU, all of 2.6 gigahertz. On the cloud, there's no issue of downloading a bandwidth because you have a gigabit. And I guess the machine is running the Windows Server 2008 data center. So we use 100 plus users 100 plus browsers per user, and we use 10 users on the machine. The reason of the limitation on users has to do with Windows. Each user on Windows is limited to a certain number of GDI objects, and using 100 browsers pretty well drains that pool. So In any case, there we get 100 browsers. So there we're done. Okay, and I'm pretty close to my 50 minutes, 45 minutes. Let me tell you what I've told you. Number one, you've got a powerful and mature, technically sophisticated engine built, number two, on top of the IE browser, but which can emulate any other browser that you care to use. And that application, the eValid application, can test AJAX in a totally realistic way without perturbing any of the AJAX timing, and most importantly, it's able to keep track of and compensate for AJAX desynchronizations if there are any. When applied to a mobile application, you see that eValid can run just fine, producing different responses by pretending that it's a different kind of browser. And in the case of an eValid operation with server loading, then you can see that we can get 100 browsers, and I just have a little animation of that I can put up. I'll wait till that's showing on your screen. So this is an animation of 100 browsers on your screen simultaneously, and every one of those browsers could be driving a mobile app or a desktop app, or one that is intended for both. So for example, if you wanted to run half of your scenarios with mobile and half of the desktop, you could, and measure the relative download counts and response times for each one of those. The possibilities are really pretty enormous.